Okay, this is complex numbers, part 7. This will be one where we work out a full problem. The question says, find the cube roots of negative 8i. So they're giving us a complex number in standard form, and we need to find the cube roots. And that usually means that you also want to give your answer in standard form also. So there's 3 parts, and it can be kind of long. So let's look at it. First, you have to take the number itself and write it in its trig form, which in this case would be the negative 8i. And then you find the roots, because it's easy to find the roots when something's in trig form. Then you take the roots and you write them in their standard form. So there's 3 parts. Okay, so for this particular one, negative 8i, z equals negative 8i. That's the same thing as 0 minus 8i. So if you plot that to look at it, you're talking about the point 0, comma, negative 8, which is on an axis. When the point is on an axis, you can't draw a triangle, but it's actually easier to figure out the modulus and the argument. So r will work out to just be 8. R is how far it is from the origin, so you can see it's 8 units. R is always positive. Sometimes people accidentally say negative 8, but it's positive 8. And then the angle, that's going to be 3 pi over 2, or you could use 270 degrees if you wanted to. So this number in standard form, negative 8i, is 8 times the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2 in trig form. Okay, so when we go and find the cube roots, then in our formula, we'll be doing n equals 3, and r will be 8, and theta will be 3 pi over 2. Or like I said, you can do degrees if you like. All right, so here's the first root. You're going to be doing the cube root of 8, and you'll be doing the angle plus no multiple of 2 pi. So basically, 3 pi over 2 divided by 3 is going to give you the angle of the first root, which works out to be pi over 2. And the cube root of 8 is 2. That's the first root. And then when you do the second root, it's going to have the same modulus as the first root, so it'll be 2. You'll be doing, for the angle, 3 pi over 2 plus 2 pi times 1. And then that divided by 3. And that will work out to be 7 pi over 6. And then the third root, when you go through its paces, the only different part is you'll be adding 2 pi times 2, but this will finally work out to be 11 pi over 6. So we have the 3 roots in their trig form. So the last part of the problem is taking each one of those roots and writing them in standard form. So here was the first root. So you basically are just going to do 2 times the cosine of pi over 2 and 2 times the sine of pi over 2. So the cosine of pi over 2 is 0, the sine of pi over 2 is 1, and then when you multiply those by 2, you're just going to end up with 2i. So that's one cube root. And the next one, you'll have to do the cosine of 7 pi over 6, which is negative root 3 over 2. And the sine of 7 pi over 6, which is negative 1/2. And then when you multiply those by 2, you'll end up with negative root 3 minus I. So that's the second root. And then the third root, very similar. It's just when you do the cosine of 11 pi over 6, it works out to be positive root 3 over 2. So you end up with the third root as being the square root of 3 minus I. Now, they usually ask you to do a sketch of the roots. It can be very simple. You don't need to do elaborate graph paper. But basically, all the roots will lie on a circle because they all have the same modulus, which in this case happened to be 2. Right? And then you can see how the roots are equally spread apart. Right? So when there's 3 roots, because you're doing cube roots, the angle in degrees would be 120 degrees. Here, it's 2 pi over 3, because I work things in radians. Right? But you just can do a simple graph, not a lot of labeling required.